Dear Sapiens, settle in. Let your breathing slow, and allow the noise of the present to fall away for a while. Because tonight we are going somewhere so far beyond our own lifetime that the people we are about to meet disappeared from the world long before history had a name, yet left something of themselves behind in every one of us. If you are listening from bed, drifting towards sleep, or simply letting this story accompany you while you work, walk, bathe, or stare into the darkness, stay with me. Because this is not a story about primitive monsters emerging from the cold, but about a human world that once existed beside ours and vanished so completely that for centuries we almost forgot it had ever been real. And before this journey ends, we will have to confront a strange possibility. Perhaps the Neanderthals did not simply disappear, and perhaps the boundary between their story and ours is far less solid than we were once taught. For hundreds of thousands of years, Neanderthals moved across Eurasia, enduring climates that could turn brutally cold, crossing landscapes that shifted with the advance and retreat of ice, and leaving behind fragments of a life that only modern science has slowly learned how to read. Their tools survived when their wooden objects, clothing, shelters, voices, and countless ordinary moments were erased. And those surviving fragments now give us an astonishingly narrow window into a world that was once full of people. So who exactly were these people? What kind of lives did they lead? What separated them from us? What connected them to us? And perhaps most importantly, what happened during the final chapter of their existence? To understand the Neanderthals, we first have to step much farther backward, because their story did not begin with them, and it cannot be separated from the much larger story of human evolution. Our genus, Homo, emerged in Africa nearly 3 million years ago, descending from Australopithecines who already walked upright and had begun doing something astonishing with stone, selecting particular rocks, striking them with deliberate force, and producing sharp edges rather than merely picking up whatever happened to lie nearby. That distinction matters, because the moment a creature begins choosing material for a purpose and modifying it according to a mental plan, we are no longer looking at simple opportunistic behavior, but at the early stages of a technological tradition. The earliest members of our genus were already experimenting with these crude stone technologies, and Homo habilis appeared roughly 2.3 million years ago using tools descended from those first traditions. Then, around 2 million years ago, Homo erectus emerged and introduced a far more elaborate approach, shaping stone on both sides to create Acheulean hand axes whose long cutting edges could be used for processing animals, working wood, digging, and perhaps even defense. These tools spread far beyond Africa as Homo erectus populations moved through Eurasia, and once those populations entered new environments, they began changing in ways that would eventually produce different human lineages. One of those later populations was Homo antecessor, which lived in Western Europe more than 1 million years ago and represents some of the earliest evidence of hominins making a long-term home in that region. Their technology remained comparatively simple, and they eventually disappeared, leaving little evidence that they contributed directly to later European populations. But another wave followed, and by the Middle Pleistocene, descendants of earlier Homo populations had developed larger brains and increasingly complex technologies, producing populations collectively associated with Homo heidelbergensis. At some point, these populations began separating from one another, and the distance between them slowly became biological as well as geographical. Around 700,000 years ago, the African populations and the European and Asian populations may already have been diverging, while hundreds of thousands of years later those differences had accumulated enough for researchers to classify some of these populations as distinct species. In Africa and parts of the Middle East, our own ancestors continued along their path, while Europe and portions of Asia became the realm of Neanderthals, and farther east another closely related population, the Denisovans, emerged. The Denisovans matter because they reveal just how complicated this family tree really was, since their ancestors shared a more recent common population with Neanderthals than either did with modern Homo sapiens. A population sometimes described as the Neandersovans appears to have expanded from Africa into Eurasia, interacting with and mixing with other archaic human populations before eventually separating into Neanderthal and Denisovan lineages. Genetic estimates place that divergence hundreds of thousands of years ago, around the period when the earliest unmistakable Neanderthal characteristics begin appearing in the fossil record. The transformation was gradual, not instantaneous, and fossils from Europe show those Neanderthal traits accumulating over time until, by roughly 130,000 years ago, the classic Neanderthal anatomy had emerged. The more recent the fossils become, the more complete the picture becomes, allowing us to move beyond vague impressions and begin reconstructing actual bodies, actual populations, and actual lives. But before we look closely at those bodies, there is a question that seems simple until you examine it carefully. Were Neanderthals actually a separate species at all? The biological definition of a species traditionally emphasizes reproduction, meaning that members of the same species can reproduce and produce offspring capable of reproducing themselves. Horses and donkeys complicate that definition because they can produce mules, but those offspring are generally sterile, and under that framework the two animals remain separate species. Neanderthals, however, produced fertile descendants with Homo sapiens, meaning that if reproduction alone were the rule, the boundary between us and them becomes much harder to defend. But evolution does not happen through a single instant in which one population suddenly becomes another, because speciation is a process that unfolds gradually as populations separate, accumulate genetic differences, respond to different environments, and sometimes lose the ability or tendency to reproduce with one another. A geographical barrier can begin the process. Genetic drift can push populations apart by chance, and natural selection can favor different traits until two populations become visibly and biologically distinct, even though there was never a single moment when one became another. So when the Neanderthals and our ancestors eventually met again, the fact that they could still have children tells us something important about the permeability of that boundary. Neanderthals were unquestionably different from any living human population, yet all modern humans carry some Neanderthal ancestry, which makes the question of whether they deserve the label separate species partly a matter of scientific classification rather than an absolute fact written into nature. Many paleoanthropologists still treat them as a distinct species because their lineage remains separate from ours for hundreds of thousands of years, and doing so is useful when describing their evolutionary history. But that classification should not fool us into thinking that biology always obeys the neat categories we give it, because the natural world is usually far messier than the names we place upon it. And that leads to an even more unsettling question. Were Neanderthals human? The answer depends on what we mean by the word, because human is not simply another taxonomic label equivalent to Homo sapiens. And if behavior, intelligence, culture, and social life are included in the definition, then the distinction becomes far less comfortable. Most anthropologists would consider Neanderthals human in that broader sense. And once we begin looking closely at what they could do, the distance between their world and ours becomes smaller still. At first glance, a Neanderthal would probably have looked recognizably human, but the closer you came, the more differences would emerge. Their bodies were generally shorter and heavier than ours, with shorter limbs, broader chests, thicker bones, and considerably more muscle, producing a compact physical structure that was unlike the average modern European, even though it remained unmistakably human. Based on long bone evidence, average Neanderthal height has been estimated at around 165 centimeters for males and 152 centimeters for females, while some individuals were considerably taller, and their average body mass was substantially greater than that of modern humans. Their bones were not simply large because they were naturally built that way. Their skeletons also recorded the demands of a life that repeatedly placed enormous stress on the body. Neanderthals appear to have carried more muscle than the average modern human, and one famous individual, La Pharisee I, stood only around 160 centimeters tall, yet weighed roughly 85 kilograms, a combination that would have produced an exceptionally powerful body. Still, their strength should not be turned into mythology, because modern athletes can reach comparable or greater levels of physical strength. And the real story is not that Neanderthals were superhuman, but that their bodies reveal what their environment and way of life demanded from them. For a long time, the most common explanation for this compact physique was brutally simple: cold. Neanderthals endured repeated glacial periods, and a shorter, broader body loses less heat because it has less surface area relative to its mass, much like the body proportions seen in some modern populations adapted to Arctic environments. Yet that explanation immediately encounters a problem, because Neanderthals living around the Mediterranean and in the Middle East retained the same basic body shape even when the climate was considerably warmer. So perhaps cold was only part of the answer, and another possibility begins to emerge when we look at how Neanderthals may have hunted. One hypothesis proposes that their heavy bodies, large muscles, short limbs, and higher proportion of fast-twitch muscle fibers were suited not to long-distance endurance, but to sudden bursts of speed during close-range encounters with prey. Their longer heel bones and correspondingly longer Achilles tendons would have been less efficient for storing energy during prolonged running, yet potentially better suited to explosive movement, suggesting that the body that kept them warm may also have helped them close the final distance between hunter and animal. Perhaps, then, both explanations belong to the same story, because an animal can be shaped by more than one pressure at the same time. Neanderthals clearly endured severe cold, and genetic evidence involving UCP1 points toward adaptations connected with heat production and fat storage, while other features of their legs and musculature suggest that short, powerful bursts of movement also mattered. Their bodies were not the product of a single environmental challenge, but of a life in which survival repeatedly demanded efficiency, strength, and rapid action. Even their shoulders have become part of this debate, because for years researchers questioned whether Neanderthals could throw effectively overhand. Later studies, however, found that their upper arms were capable of tolerating both pushing and throwing stresses, while injuries recorded on Neanderthal arm bones are consistent with repeated spear throwing. So although their shoulder mechanics may not have matched ours perfectly, the evidence no longer supports the idea that they were incapable of throwing weapons, and that matters because it changes how we imagine their hunts. Other details of their bodies reveal the same pattern of subtle difference. Their thumbs had relatively long distal bones that may have provided a broader and stronger grip, while their broad, barrel-shaped chests and long ribs may have accommodated a large diaphragm and substantial lung capacity. And then, moving upward toward the head, the Neanderthal face begins to emerge from the fossil record with features that would have made their presence unmistakable at close range. Imagine standing close enough to see one clearly, and the first feature you might notice would be the heavy brow ridge crossing the forehead. Those ridges may have helped protect the face from impacts, while the large eyes and enlarged visual regions of the brain suggest that Neanderthals may have been especially capable of seeing in low-light conditions, perhaps an advantage during hunting around dawn and dusk. Behind the skull, the occipital region was pronounced, and together with their large eyes it points toward a nervous system that devoted substantial resources to processing visual information. Their nasal region was also distinctive, although not quite in the exaggerated way older reconstructions sometimes suggested. Their nasal passages and sinuses were large, and their sinuses were considerably more spacious than those of living human populations, potentially allowing them to process large amounts of cold air while warming it before it reached the lungs. The same anatomy seen through the wrong lens can make a face look strange, but seen through adaptation, those features begin to look less like deformities and more like solutions to problems their environment repeatedly presented. Then there was the feature they lacked, a chin. To modern humans, the chin feels like such an ordinary part of the face that its absence seems almost shocking, yet most other hominins and primates do not possess one, and the human chin may have emerged through processes associated with the particular social and anatomical evolution of our species. Neanderthals had no chin, but they had powerful jaws, large teeth, and shovel-shaped incisors, while their children developed their teeth several months earlier than modern human children, potentially allowing them to begin consuming solid food sooner. The final striking feature of their skull is the shape itself, because unlike our relatively rounded, globular cranium, the Neanderthal skull stretched backward in a longer, flatter form. Inside that unusual shape was a very large brain, with average volumes estimated at roughly 1,640 cubic centimeters for males and 1,460 for females, numbers that at first appear to place Neanderthals comfortably above modern humans. But here again, the obvious answer is not the correct one, because brain size only begins to make sense when we consider the size and structure of the entire body. A large animal naturally tends to require a larger brain, just as a whale has a much larger brain than we do, without implying that whales possess a human-like level of intelligence. Once brain size is adjusted for body size, Neanderthals become somewhat less exceptional, falling within the broad range of modern human variation rather than standing outside it as creatures with impossibly enormous brains. And then the real question begins, because the number of cubic centimeters tells us far less than the way those centimeters were organized. Endocasts suggest that Neanderthal brains differed in the relative size of several regions, including smaller parietal lobes and a smaller cerebellum, areas involved in processes that include aspects of memory, motor coordination, language, creativity, and social behavior. That does not mean Neanderthals were incapable of these things, because brain anatomy does not translate so neatly into a simple scale of intelligence, but it does tell us that their minds were not merely copies of ours placed inside different skulls. Their brains were organized differently, and that difference may be one of the most important clues we possess about how their experience of the world differed from our own. Their visual and sensory systems appear to have occupied a relatively larger proportion of their brains, while Homo sapiens had comparatively smaller visual systems and therefore more neural tissue available for other regions. Neanderthals also appear to have reached physical maturity faster than modern humans, with adulthood arriving at roughly 15 years of age, almost a decade earlier than in our own species. So when we look into the Neanderthal skull, we are not simply seeing a larger or smaller version of a human brain, but a different neurological arrangement belonging to a different human lineage. That difference is important, because it is easy to become so fascinated by the similarities that we forget the Neanderthals really were different. Yet their differences do not make them less interesting, and they certainly do not make them less human in the broader sense, because anatomy alone cannot tell us whether a person loved someone, feared the darkness, remembered an old story, or felt wonder when looking upward into the night. To find those things, we have to move beyond bone and into the traces left by behavior. Their appearance also varied considerably across the enormous territory they occupied. Neanderthals living in different regions could have had different combinations of skin, hair, and eye color, and genetic evidence indicates that some populations had dark skin and dark eyes, while at least some individuals probably had lighter skin and red hair. The important point is that there was no single Neanderthal appearance, just as there is no single modern human appearance, and the old image of one uniform type collapses when the evidence is examined closely. Their bodies were not covered in the heavy layer of fur sometimes imagined in popular culture, either. The genetic history of reduced human body hair predates the separation between our lineage and the Neanderthal lineage, meaning Neanderthals almost certainly had relatively hairless skin with ordinary body hair much like our own. So the closer we look, the stranger the old caricature becomes, because the supposed beast begins disappearing and a recognizably human body takes its place. But anatomy is only the beginning, because these people did not survive hundreds of thousands of years through biology alone. They possessed technologies that allowed them to transform very small amounts of raw material into tools capable of cutting, scraping, shaping, hunting, processing food, and working other materials. Stone survives exceptionally well compared with wood, leather, fiber, and flesh, which means the archaeological record gives us an unusually stone-heavy picture of a culture that was almost certainly built from far more than stone. To understand what makes their tools remarkable, we have to return briefly to the older technologies that came before them. Earlier hominins produced simple hand axes by removing flakes from stone, while the Acheulean tradition introduced more deliberate shaping on both sides. But around 300,000 years ago, another approach appeared across Europe, the Middle East, and North Africa. This was the levallois technique, in which the core itself was carefully prepared so that a precisely shaped flake could be struck from it, turning the core into something like a plan for producing a desired tool rather than merely a lump of stone to be broken apart. The genius of levallois was not simply that it produced sharp flakes, but that it used raw material efficiently. By preparing the core into a particular shape and striking at a prepared platform, a large preferential flake could be removed, creating a cutting edge that made excellent use of the available stone and could later be retouched when its edge became damaged. For mobile hunter-gatherers, that efficiency mattered enormously, because carrying stone across a landscape was costly, and getting more useful cutting edge from less raw material meant carrying less weight without sacrificing function. Many Neanderthal tools were therefore not large hand axes held like weapons, but flakes that could serve different purposes depending on how they were used or modified. A sharp flake might begin as a cutting tool and later be retouched into a scraper, while other flakes could be shaped into converging points capable of becoming spear tips. Once a stone point was attached to a wooden shaft, however, the simple-looking artifact sitting in the archaeological display was no longer a simple stone at all, but one component of a composite weapon. And this is where the Neanderthal technological story becomes much more interesting than the surviving stones suggest. Evidence of abrasion and natural adhesives shows that Neanderthals attached stone points to wooden shafts, sometimes using slots in the wood and sometimes employing substances such as natural tar or bitumen to hold the components together. The moment you imagine the missing wooden shaft, the adhesive, the binding, and the stone point working as one system, the technology suddenly becomes far more sophisticated than the isolated stone artifact would ever reveal. Some of these points were clearly used in hunting, while others appear to have served woodworking or butchery purposes. In one study of more than 100 Levallois points, only a small number showed damage consistent with use, but some of those exhibited patterns associated with penetration into animal tissue, and other archaeological finds include actual stone fragments embedded in animal bones. This evidence does not mean every Neanderthal point was a spearhead, but it does establish that spear technology was part of their technological world. Later Neanderthal points could become more elaborate, including bifacial forms produced with considerable skill. Some were repeatedly resharpened until they could no longer be effectively used, showing that a tool was not necessarily disposable after its first task, but could be maintained and altered over time. And when one of these carefully shaped points was finally abandoned, what remained was only the stone, while the shaft, binding, adhesive, and countless hours of labor that had turned it into a weapon vanished from the archaeological record. Natural adhesives reveal another layer of this hidden complexity. Birch tar, pine resin, beeswax, and bitumen have all been identified at Neanderthal sites, and one remarkable piece of birch tar even preserves impressions of wood, stone, and a Neanderthal fingerprint. Suddenly, the invisible hand of the maker becomes visible, not through a written name or portrait, but through the pressure of a fingertip left behind in a substance that hardened tens of thousands of years ago. Pine resin could be used directly, while the addition of beeswax could create a stronger adhesive, and chemical residues indicate that Neanderthals may have deliberately combined these materials. Bitumen provided another naturally available adhesive, and traces found on the teeth of Neanderthals at El Sidron have even led to the possibility that mouths were used while attaching tools, perhaps holding one component in place while the other hand applied adhesive. There are other possibilities, including glue made from cooked skin or tendon, but for those we have to admit that the evidence is missing, and that distinction between evidence and possibility must remain clear. Microscopic polishing provides another clue, because attaching a tool to a handle can leave characteristic or patterns on the stone. In some sites, a surprisingly large proportion of artifacts show traces consistent with hafting, meaning that what appears to be a collection of rough stone flakes may actually represent a much more complex system of handles, shafts, bindings, and adhesives that have mostly disappeared. The Neanderthal technological world may therefore have looked far more sophisticated than the surviving stone record alone would lead us to believe. Wood was especially important, even though it is one of the materials archaeology is least likely to preserve. Neanderthals could use stone flakes, blades, notched tools, denticulates, and burins to cut, scrape, carve, and shape wood, producing objects whose original existence can sometimes only be inferred from impressions or rare surviving fragments. And then came a discovery that transformed our understanding of what they could do: a group of wooden weapons preserved at Skåningen. The Skåningen weapons date back more than 300,000 years and include complete wooden spears among the oldest preserved wooden tools ever discovered. Because wood normally disappears within a relatively short time, their survival required an unusual combination of rapid burial and waterlogged conditions, preserving objects that would otherwise have vanished completely. Their shape, balance, and construction indicate deliberate design rather than accidental sharpening, and experiments with replicas have shown that at least some could perform effectively as throwing weapons. Other wooden objects from the same site may have included throwing sticks, roasting implements, and handles for stone tools. A much older wooden spear from the English coast, dating to roughly 420,000 years ago, suggests that wooden weapon technology existed among early populations ancestral to later Neanderthals long before the classic Neanderthal form appeared. So when we imagine a Neanderthal carrying a stone point, we should not imagine a stone floating alone in their hand, because the invisible wooden world surrounding that point may have been just as important as the stone itself. At Abric Romani, the evidence becomes stranger and in some ways more haunting, because the wood itself has vanished while its impressions remain preserved in travertine. Flat objects, long posts, handles, and an unusual implement resembling a knife or digging tool left behind their shapes, even though the material that created those shapes disappeared thousands of generations ago. It is a reminder that much of Neanderthal technology may now exist only as empty spaces in stone, waiting for someone to recognize the shape of something that no longer exists. Bone and shell added, yet more possibilities. Neanderthals used animal bones as retouchers for reshaping stone edges, sometimes selecting bones from large animals and even, in one extraordinary case, using a fragment of a Neanderthal skull as a retoucher, while other bone tools may have assisted in controlled indirect percussion for producing more refined stone implements. At some Mediterranean sites, shell tools were also used for cutting meat, scraping hides, and working wood, and some shells had been collected alive from shallow water, meaning that the people who made these tools had deliberately entered aquatic environments to obtain them. The sea hides an enormous amount of this story, because rising water levels have covered many ancient coastal sites. What survives on land is therefore only a fraction of what Neanderthals may have done along ancient shorelines, where shells, fish, marine mammals, and other resources could be collected or hunted. The archaeological record does not necessarily tell us what they did most often. It tells us what happened to survive. Then there is fire, perhaps the most important technology of all. Fire provided warmth, helped process food, extended the usable hours of the day, illuminated dark shelters, supported tool-making and hide-working, and created a place around which people could remain together after darkness had fallen. At Abric Romani, multiple hearths arranged along a shelter wall have been interpreted as individual fires positioned to provide warmth to sleeping people, a simple arrangement that transforms an archaeological feature into a scene of bodies lying close to the heat during a cold night. Cooking was another enormous advantage. Burned bones indicate that meat and marrow were commonly exposed to fire, while evidence from charred plant remains suggests that some plant foods were cooked as well, and cooking would have softened tough tissue, improved digestibility, increased nutrient absorption, and reduced harmful pathogens. The fire therefore did more than keep a person alive in the cold. It changed the energetic value of the food that person consumed. But fire also changed time itself. A person sitting beside a flame after sunset could continue making tools, working hides, shaping wood, preparing food, or simply remaining awake and interacting with others long after natural daylight disappeared. And if you imagine a small group gathered around those flames, talking about what happened during the day, planning what would come next, or perhaps repeating stories handed down from earlier generations, the archaeological site begins to feel less like an abandoned cave and more like the remains of a home. Yet another question follows naturally. Could Neanderthals create fire themselves, or were they dependent on flames produced by lightning and other natural events? Natural fire could be collected and maintained for long periods, but relying entirely on unpredictable wildfires would have been extremely risky in cold environments, and archaeological evidence from several sites suggests that at least some Neanderthals had methods for deliberately producing fire. Some stone tools show repeated abrasion consistent with striking hard minerals such as pyrite, which can produce sparks, while manganese dioxide appears to have been processed at certain sites in a way that could have helped lower the ignition temperature of wood. The evidence remains debated in places, because manganese could also have been used as pigment, but the possibility is difficult to ignore when several lines of evidence begin pointing toward deliberate fire production. Even chemical traces preserved in ancient cave sediments have been interpreted as evidence that some fires were created independently of natural sources. Still, caution matters. because evidence that some Neanderthals could make fire does not prove that every Neanderthal group did so in the same way or with the same frequency. Some techniques, such as friction fire, would leave almost no archaeological trace at all, meaning that the absence of evidence may simply reflect the fragile nature of the technology rather than its absence from Neanderthal life. And this is one of the recurring mysteries of their story. How much have we failed to see simply because the materials they used were the materials least likely to survive? Their hearths were often simple, sometimes nothing more than circular areas of burning, while more permanent fires could be surrounded by stones or shallow constructions that altered the way heat moved through the shelter. Different types of wood were burned, dead branches were commonly used, and in environments where wood was scarce, animal bone could provide fuel that burned for longer periods. Some groups even transported brown coal from considerable distances, suggesting a detailed understanding of resources in their surrounding landscape. Fire could also be carried rather than recreated from nothing. A glowing ember wrapped in suitable material could remain alive for hours, allowing a group to transport heat from one camp to another, although there is no direct evidence that Neanderthals used every method known from later human societies. Even so, the possibility reminds us that their mobility was not simply movement from one place to another, but the movement of an entire technological system. And then winter demanded another technology: clothing. Direct Neanderthal clothing almost never survives because skin, fiber, cordage, and woven materials decay, yet cut marks on animal bones show that hides were deliberately removed, stone tools preserved where from working leather, and the teeth of Neanderthals from colder regions show heavy were consistent with using their mouths while processing hides. Their clothing may therefore have been one of the most important technologies they possessed, even though almost none of it remains. Preparing a hide was not a simple task. Flesh and fat had to be removed before the skin decayed. Scraping required time and force. Dried hides had to be rehydrated and stretched. Fats such as marrow or brain could be worked into them to increase softness and water resistance, and further treatment could make the final material more durable. Evidence from one site even suggests that Neanderthals may have used tannin-rich bark to tan hides, creating leather that could survive longer and resist decay more effectively. Thermal modeling suggests that clothing requirements varied enormously with location and climate. In colder regions, Neanderthals may have needed to cover most of their bodies during winter, with some estimates exceeding 90% of the body being covered during severe glacial conditions in Central Europe, while populations living near the Mediterranean could survive with considerably less. So what did those clothes actually look like? And were they sewn into fitted garments or simply wrapped around the body? No-eyed Neanderthal sewing needle has been discovered, but fitted clothing does not require the exact sewing technology seen in later populations. A pointed awl made from stone, bone, or wood could create holes, and cord made from leather, tendon, or plant fiber could then pass through those holes to hold pieces together. Evidence from France indicates that plant fibers were being twisted into cord tens of thousands of years ago, although because such materials decay so easily, we cannot know how widespread the practice was. Different hides would have served different purposes. Deer skin could provide flexible material, while thicker hides from animals such as bear, bison, or woolly rhinoceros may have offered greater insulation, and exceptionally heavy hides could perhaps have served better as blankets or shelter materials than as clothing. Soft coverings for feet may also have existed during severe winters, even though most surviving Neanderthal footprints appear to have been made by bare feet. Leather and cordage would have been useful for far more than clothing. Bags, bedding, shelter coverings, and containers could all have been made from animal materials, while carrying equipment would have been essential for a mobile population that could not simply leave its tools behind each time it moved. Imagine one group preparing to travel, gathering weapons, stone, leather, food, fire materials, bedding, and the equipment needed to make more equipment, because mobility meant carrying not only possessions but the means of rebuilding those possessions wherever they went. That brings us to the central activity that connected almost every part of their technology: hunting. Neanderthals lived in landscapes filled with animals of extraordinary size, and the evidence from their tools, prey remains, and skeletal injuries allows us to reconstruct hunts that were not merely acts of strength, but required knowledge of animal behavior, movement, terrain, timing, and the coordinated actions of several people. The question is no longer whether they could kill large animals, but how they managed to approach creatures capable of killing them in return. At Skåningen, horses weighing more than 500 kilograms were probably hunted around an ancient lakeshore where their movement could be restricted. Rather than simply charging after an animal across open ground, hunters could use the landscape itself, guiding prey toward a place where it became easier to surround or approach. The ability to kill such large animals with relatively simple-looking weapons implies planning and a deep understanding of animal behavior. Another site preserves more than 100 fallow deer, including individuals with puncture injuries consistent with close-range spear attacks. Reaching the effective range of a fast, alert animal would have required concealment, patience, and coordination, while the Neanderthal body itself may have been particularly well suited to the final explosive movement required to close the distance. Hunting, in other words, was not simply about possessing a spear. It was about knowing when and where to use it. A fragment of a Levallois point embedded in the vertebrae of a wild ass from Syria offers another remarkable clue. The trajectory and impact energy indicate that the weapon was probably thrown rather than simply thrust, and the resulting injury would likely have caused rapid paralysis and death. This does not overturn the broader evidence that close-range thrusting was common, but it proves that Neanderthal spears could sometimes become projectiles when circumstances demanded it. Yet the injuries on Neanderthal skeletons reveal the price of such hunting. A very high proportion of known Neanderthal remains show healed major trauma, and a substantial fraction of individuals appear to have suffered serious injuries during their lives, a pattern often compared with injuries found in modern populations whose lifestyles involve close contact with dangerous large animals. Every successful hunt could therefore carry a hidden cost, because the distance between hunter and prey was often close enough for the animal to fight back. Some of their prey were enormous. Woolly mammoths, straight-tusked elephants, rhinoceroses, aurochs, giant deer, horses, bison, and other large mammals move through the same world. And while it would be wrong to imagine every Neanderthal group routinely killing the largest animals available, the evidence shows that such animals sometimes became part of their hunting economy. Perhaps the most dangerous prey were not always the most common, and perhaps some of these enormous animals were targeted during periods when other resources were scarce, but the possibility of coordinated group hunting makes the idea far less impossible than it might first appear. Young mammoths may have presented a different opportunity. At Spy Cave in Belgium, an unusual concentration of young mammoth skulls has been interpreted as possible evidence that Neanderthals targeted young animals, perhaps in part because their brains provided valuable fats and nutrients. The idea is striking because the smallest members of a giant species can be simultaneously the easiest to kill and one of the most nutritionally valuable parts of an otherwise formidable animal. But the Neanderthal diet was not built entirely around giants. They hunted deer, reindeer, ibex, birds, small mammals, reptiles, and other smaller prey, and the archaeological record may have exaggerated the importance of large animals simply because large bones preserve better. Rabbit remains from Mediterranean sites, for example, suggest that Neanderthals were deliberately taking adult rabbits, which are surprisingly difficult animals to catch and may have required traps, snares, or other methods that left little or no archaeological trace. Birds present an even more intriguing problem. At Gibraltar, remains from more than 100 bird species have been recovered, including ground-dwelling birds as well as eagles and vultures, suggesting that Neanderthals were capable of exploiting prey that required very different approaches. Some birds could be captured by hand in particular circumstances. Others might have been taken with thrown objects or traps, while birds of prey may have been vulnerable when approaching carcasses, and the unusual treatment of eagle bones raises the possibility that these birds had significance beyond simple food. Reptiles also entered the diet. Burned tortoise remains demonstrate that at least some Neanderthal groups were collecting and cooking them, while freshwater turtles were exploited in other regions, and changes in tortoise size over time may even reflect intense hunting pressure. It is another reminder that these people did not simply choose the largest animal they could find, but adjusted their behavior to whatever resources the environment offered. Water was another source of food and materials. Neanderthals living in southern Europe consumed shellfish, crabs, seals, fish, dolphins, and seabirds, and at Figueira Brava in Portugal hundreds of shells and remains of marine mammals preserve evidence of substantial coastal exploitation. But how exactly were those resources obtained, especially the dolphins, remains uncertain, and the lack of obvious fishing hooks or net weights means that collection, shallow water hunting, opportunistic capture, and other methods all remain possible. Some Neanderthal skulls even preserve bony growths associated with repeated exposure to cold, wet water, a condition sometimes called surfer's ear. This has been used as possible evidence that certain individuals repeatedly entered cold water, perhaps while gathering aquatic resources, although the precise behavior cannot be recovered from the bone alone. What we can say is that at least some Neanderthal populations were comfortable exploiting aquatic environments rather than treating the coastline as a boundary they could not cross. Then there are insects, a food source that leaves almost no archaeological trace. Rotten wood, larvae, insects gathered from animal remains, and other small resources could have provided nutrients during difficult periods. And while there is no direct evidence proving Neanderthals systematically exploited insects, their general adaptability makes the possibility difficult to dismiss. The presence of beeswax in some adhesives also strongly suggests that honey and other hive products were being collected, turning the same animal that provided wax into another source of food. And then the story takes a darker turn, because one of the foods Neanderthals sometimes consumed was other Neanderthals. Evidence from several sites shows that cannibalism occurred, including remains from the French site of Mulagursi, where multiple individuals were butchered and processed in ways similar to the animals they normally hunted. Yet the evidence should not be turned into a portrait of a permanently cannibalistic people, because the pattern appears rare, and one interpretation is that such behavior may have emerged during extreme nutritional stress rather than as an ordinary part of life. L. Sidron presents an even more disturbing possibility, because 13 individuals appear to have belonged to a coherent family group whose bones show extensive cutting and breakage. The evidence has been interpreted as an episode in which an entire family was killed and consumed by another group, perhaps during severe nutritional stress. But even here the remains do not allow us to reconstruct motives with certainty. What they do show is that Neanderthals, like other humans, were capable of acts that could be both brutally practical and deeply tragic. Another Belgian site contains evidence that Neanderthal bodies themselves were butchered in ways closely resembling the treatment of their ordinary prey. Yet when the entire Neanderthal fossil record is considered, cannibalism does not appear common enough to define their society, and describing all Neanderthals as cannibals would be no more accurate than describing all modern humans that way. The evidence instead points toward occasional episodes, some perhaps connected to hunger, conflict, or circumstances that we can no longer reconstruct. Whatever they ate, they needed enormous amounts of energy. Their compact but muscular bodies, large brains, heavy bones, cold environments, and physically demanding mobility all came with metabolic costs, and estimates suggest that a Neanderthal might have required several thousand calories every day, with some circumstances potentially demanding far more. A small group could therefore require several medium-sized animals each week simply to remain alive, while a large kill could provide enough food to support the group for a much longer period. That raises another problem, because eating only very lean meat can itself become dangerous when fat and other nutrients are insufficient. Neanderthals would therefore have needed to value fatty tissues such as brains, marrow, organs, tongue, eyes, and other nutrient-rich parts, and the heavy processing of long bones and skulls suggests that they did exactly that. The survival strategy was not simply to obtain meat, but to extract as much usable energy as possible from every animal they managed to bring down. Plants remained important, especially during warmer periods. Nuts, fruits, seeds, tubers, mushrooms, bark, and other plant foods appear in the archaeological and dental evidence, with sites in the Middle East preserving remains of acorns, walnuts, pistachios, hazelnuts, pine nuts, dates, figs, olives, and grapes. The proportions varied with climate and geography, but the overall picture is of flexible diets rather than a single universal Neanderthal menu. Dental evidence supports that broader interpretation. Some individuals consumed a mixture of animal and plant foods, while plant DNA preserved in dental calculus has occasionally been misinterpreted as evidence of vegetarian Neanderthals, even though the surrounding evidence points toward a much more varied diet. The real lesson is not that Neanderthals belonged to one dietary category, but that they adjusted what they ate to the resources available in the environment around them. They also had to decide how to prepare that food. Meat could be roasted on wooden spits, buried in hot embers, or perhaps cooked in water using heated stones and containers made from materials such as bark, animal stomachs, or other organic substances, while a rock basin at Abercrombie may have served a similar purpose. Plant foods could also be cooked, and residues of aromatic plants such as chamomile and yarrow have even been found in dental calculus, suggesting that some foods may have been seasoned or perhaps used medicinally. Food preservation would have been equally important. A large kill could produce more calories than a group could consume immediately, so drying, smoking, freezing, salting where available, or fermenting may have allowed food to remain useful after the hunt was over. Evidence from sites containing unusually large concentrations of animal remains suggests that at least some Neanderthal groups may have processed and preserved food in anticipation of future scarcity rather than simply consuming every animal as quickly as possible. But obtaining food also made Neanderthals vulnerable to other predators. Cave lions, wolves, leopards, bears, and hyenas shared their landscapes, and the enormous cave bear could stand several meters tall and weigh close to 1,000 kilograms, while also competing with Neanderthals for caves and shelter. Sometimes these animals were competitors, sometimes they were threats, and sometimes the relationship may have been reversed because Neanderthals occasionally hunted predators themselves. Cave hyenas were especially interesting competitors because they occupied ecological niches that overlapped heavily with those of Neanderthals. Both could exploit similar prey and similar shelter, yet differences in hunting strategy may have allowed them to coexist, with hyenas often taking weaker or younger prey while Neanderthals targeted healthier animals, though hyenas could also steal kills through intimidation. The landscape was therefore not simply a stage on which Neanderthals hunted animals. It was a constantly shifting network of competition in which the hunters themselves could become prey. And all of this brings us closer to something more intimate than tools or anatomy: the Neanderthal social world. We know they lived in groups, moved together, hunted together, cared for injured individuals, and depended upon one another for survival, because an animal capable of surviving severe injury long enough to heal was rarely surviving through individual strength alone. Somewhere behind every healed fracture was probably another person who helped that injured individual obtain food, remain warm, and survive long enough for the bone to knit. The same applies to age. Neanderthal groups included children, adults, and older individuals, and the survival of people who had suffered serious physical damage suggests that communities sometimes carried burdens that provided no immediate advantage to the individual doing the helping. This is one of the quietest forms of evidence for compassion, because a healed injury tells us nothing about the sound of the voice that helped, but it tells us that someone was there. Their knowledge of the landscape must also have been extraordinary. A mobile hunter does not survive by looking at the ground and seeing only rocks and trees, because the environment becomes a system of signals, where animals travel, when plants appear, where useful stone can be found, which routes remain passable, where shelter can be found, and how weather changes the behavior of everything around them. The landscape was not simply where they lived. It was a source of information they had to read continuously. This is why their apparently slow technological change should not automatically be interpreted as cognitive stagnation. Innovation is strongly influenced by population size, and Neanderthal populations were often small and fragmented, meaning that a new idea arising in one group had fewer opportunities to spread rapidly through a vast connected population. When modern humans later expanded and their populations increased, cultural innovations became more frequent and spread more rapidly, but that does not prove that Neanderthals were biologically incapable of innovation. In fact, our own ancestors had lived with relatively similar technologies for enormous spans of time before experiencing the later acceleration of cultural change. It is therefore possible that the difference between Neanderthals and Homo sapiens was not simply a difference in anatomical intelligence, but partly a difference in population structure, cultural connectivity, and the way ideas accumulated and spread. And if circumstances had been different, if populations had remained separated differently, could the Neanderthals have become the humans whose descendants eventually spread across the world? That possibility is impossible to test, but it exposes something important about our own story. Neanderthals were certainly capable of surviving with their anatomy, but their cultural traditions did not undergo the same rapid transformation that eventually characterized the Upper Paleolithic, where new stone industries, bone technologies, and forms of art appeared and changed over relatively short intervals. Their culture may have been absorbed, replaced, or simply interrupted by forces that had little to do with whether their brains were capable of producing new ideas. And now we arrive at the question that changes everything. If their technology and culture did not simply reveal a fundamentally inferior species, what really happened when Homo sapiens entered their world? The easy answer would be conquest, replacement, and extinction, but the evidence points towards something much more complicated, because the two populations did not remain completely separate. They met, they interacted, and in at least some cases they had children together. There may have been conflict, competition, and displacement, but there was also something else that is much harder to imagine when we rely on old stories of primitive humans. There were families formed between populations that had been separated for hundreds of thousands of years, children who inherited genetic material from both lineages, and communities in which the boundary between Neanderthal and modern human was no longer absolute. Their disappearance was therefore not a clean vanishing, but a process of mixing, shrinking populations, and eventual absorption. Imagine the final generations of Neanderthals not as a lonely species standing at the edge of a cliff, but as people living in communities where ancestry could already be mixed. A child might have inherited traditions from one lineage and biology from both, while an older Neanderthal could have carried knowledge of pigments, stoneworking, weather, animals, and landscapes into a family whose descendants would eventually be classified simply as modern humans. The final Neanderthal voices may therefore have spoken languages shaped by more than one human lineage, even though none of those voices survived long enough for us to hear them. Their technological traditions also left a legacy that did not necessarily vanish at the moment their distinct population disappeared. Techniques, knowledge, materials, and perhaps cultural practices could persist through interaction, imitation, and inheritance even when the population that first developed them ceased to exist as a recognizable group. But the deepest legacy was not a stone point, a scraper, or a piece of tar, because their most enduring inheritance was biological. Neanderthal genetic material survives throughout modern human populations today. Some of those inherited genes influence biological functions such as immune responses and adaptations connected to environmental conditions, meaning that pieces of Neanderthal biology remain active inside bodies that look completely modern. So when we ask whether Neanderthals went extinct, the answer begins to become strangely uncomfortable. Their anatomy disappeared as a distinct population. Their communities eventually vanished, and the landscapes they knew were transformed by later climates and later humans. Yet part of their genetic legacy continued forward, passing from one generation to another until it reached people who could never have known where those fragments came from. The people disappeared, but some of their biology continued walking. And perhaps that is why the final chapter of the Neanderthal story feels so different from the beginning. At first, they seemed like distant creatures separated from us by hundreds of thousands of years, but now their story has become tangled with our own, because every modern human carrying Neanderthal ancestry is, in a literal biological sense, carrying part of that vanished population forward. The extinct relative has become part of the living descendant. Think back to the bodies we described earlier, compact and powerful, adapted to cold and close-range hunting, carrying brains organized differently from ours. Think of the hands shaping stone, the fingers pressing tar into wood, the arms gripping a spear, the teeth holding leather while another person worked it, and the eyes watching the movement of animals through a landscape they knew intimately. These were not abstract evolutionary specimens. They were individuals moving through ordinary days that, to them, were simply life. They knew hunger and cold, but they also knew warmth. They knew danger, but they also knew cooperation, and somewhere around their fires they almost certainly spent time doing things that leave almost no archaeological trace. Talking, remembering, teaching, waiting, watching children, caring for the injured, and wondering about things we can no longer ask them to explain. Their greatest silence is not the silence of an empty landscape, but the silence of people whose voices were never recorded. They also created things whose purpose went beyond immediate survival. Pigments, feathers, markings, cave art, and carefully selected objects suggest that some Neanderthal behavior cannot be reduced to calories and weapons, because humans do not create meaning only when survival requires it. A feather can be carried because it is beautiful, pigment can be prepared because color matters, and an image can exist because someone wants another person to see what exists inside their mind. That is where the old caricature finally collapses. The Neanderthal was once imagined as a brute, a creature with heavy brows and little thought. But the archaeological record instead reveals a human lineage capable of sophisticated toolmaking, fire use, hunting, hide working, social cooperation, care for the injured, treatment of the dead, and forms of symbolic behavior. They were not identical to us, and pretending they were would erase their uniqueness, but neither were they the mindless creatures that older generations imagined. Their lives may even have been richer than ours in certain forms of environmental knowledge. A Neanderthal who lived for decades in one region would have learned the timing of animal migrations, the properties of different stones, the behavior of dangerous predators, the locations of useful plants, the safest routes through difficult terrain, and the subtle signs that weather was about to change. To that person, the landscape was not scenery, it was a language. And perhaps this is the point where we should stop and ask ourselves what exactly separates us from them. Is it the shape of a skull, the size of a brain region, the number of tools produced over a particular period, or the speed at which ideas spread through a population? Or is the boundary much less secure, because the same qualities we use to define ourselves, adaptation, cooperation, creativity, care, violence, curiosity, and the ability to transform the environment, were already present in another human lineage long before our modern world existed? The more we learn, the harder it becomes to place the Neanderthals safely in the category of other. Their bodies were different, their brains were organized differently, their populations were smaller, their cultural trajectories followed a different path, and their technology developed in ways that were not identical to ours. Yet difference does not erase kinship, and extinction does not erase ancestry. For hundreds of thousands of years, they endured changes that would have destroyed less adaptable populations. They survived repeated glacial periods, shifted their diets when environments changed, exploited new resources, developed technologies from stone, wood, bone, shell, leather, and fire, and maintained social groups under conditions that demanded constant cooperation. Their survival was not a brief experiment, but an extraordinarily long chapter in human evolution. And then, gradually, the chapter closed. There was no single moment we can point to and call the final day, no last Neanderthal standing alone while the world around him disappeared, because extinction is usually a process rather than a scene. Populations shrink, territories change, groups meet, genes mix, resources fluctuate, and eventually a lineage can cease to exist as a distinct population even while parts of it continue inside another. That is why the phrase Neanderthal extinction can be misleading if we imagine it as absolute disappearance. Their distinctive anatomy is gone, their communities are gone, and no Neanderthal group exists today in the form it once did, but their genetic legacy survives within modern humanity. In that sense, the final Neanderthals did not simply vanish into nothing. Some part of them crossed the boundary into us. Every generation of modern humans carrying those inherited sequences becomes another link in that chain. The people who lived through the ice ages did not know that thousands of generations later their descendants would possess pieces of their genetic inheritance, because they had no reason to imagine such a future. Yet that is exactly what happened, and it means that the story we have been following does not end with a fossil buried in European soil. It ends inside living bodies. It ends in biology that crossed an enormous distance in time without needing a written record, a monument, or a name. It ends with the unsettling realization that when we study the Neanderthals, we are not simply looking backward at strangers, but looking backward at one of the human populations that helped become us. So as the story begins to quiet, remember the image of those people beside a fire. Imagine only the glow on a face, a hand resting near the warmth, and the dark beyond the shelter where the cold continues moving across the land. Somewhere in that darkness, thousands of generations ago, a Neanderthal may have looked toward the same night sky that our ancestors saw, without knowing that one day another human would look backward through time and try to understand who they were. We can never recover their voices exactly. We can recover stone, bone, ash, pigment, footprints, genetic fragments, traces of adhesives, impressions of vanished wood, and the marks left by hands that have been gone for an almost unimaginable length of time. But the actual words spoken around those ancient fires are beyond our reach. What remains is enough to tell us that there were people there, and that their lives were far more complex than the silence of the fossil record once suggested. We have followed their bodies through cold landscapes and watched their anatomy reveal the pressures of survival. We have watched their hands turn stone into cutting edges, wood into weapons, hides into clothing, fibers into cord, and natural substances into adhesives. And we have seen how even the smallest surviving traces can expose an entire technological system that otherwise disappeared. We have followed them into hunts where a single mistake could mean a broken bone or death, and into moments where an animal weighing hundreds or thousands of kilograms stood between a group and the food it needed to survive. We have seen that their lives were physically demanding, nutritionally expensive, and dangerous, yet also flexible enough to include plants, birds, rabbits, reptiles, marine resources, and whatever else their environments offered. We have also encountered the darker evidence, including hunger, violence, and cannibalism, and these discoveries force us to resist the temptation to turn ancient people into either monsters or saints. Neanderthals could be compassionate and violent, cooperative and desperate, creative and practical, just as human beings have always been capable of holding contradictory qualities inside the same species and sometimes inside the same individual. Perhaps that is why their story feels so familiar. Their world was unimaginably different from ours, but the basic problems were not. Finding food, staying warm, protecting children, caring for injured people, making tools, remembering useful knowledge, moving through dangerous places, and deciding what to do when resources became scarce. Strip away the ice, the stone, and the vanished landscapes, and the human questions remain. And perhaps the deepest lesson is not that Neanderthals were more like us than expected, but that our idea of us has always been too narrow. Human history did not begin with modern Homo sapiens standing alone, because our lineage grew alongside other human populations, separated from them, met them again, competed with them, lived beside them, and in some cases became biologically connected to them. The human story was never a single straight line. It was a branching story, filled with populations that appeared, changed, moved, met, mixed, disappeared, and sometimes left fragments of themselves inside descendants they could never have imagined. The Neanderthals are one of the clearest examples of that complexity because their disappearance seemed absolute until genetics revealed that it was not. Their fossils tell us that the population ended, but their DNA tells us that part of the population continued. So when we say that Neanderthals are extinct, we have to choose our words carefully. Their distinct population is gone, their characteristic anatomy no longer walks across Eurasia, and their communities have vanished into the archaeological record, but their genetic inheritance survives in living humans. They are extinct in one sense, and still present in another, and those two statements can both be true at the same time. That paradox is perhaps the most fitting ending for their story. A people who survived ice ages, predators, hunger, changing climates, and the arrival of another human population ultimately became part of the population that replaced them, meaning that their final legacy was not simply a disappearance, but a transformation. They stopped being Neanderthals as a separate people, yet they did not disappear entirely from the human story. Their story now lives in fossils and fragments, but it also lives in our genes, in the questions we ask about human origins, and in the uncomfortable realization that the boundary between ancestor and relative is not always as clean as we imagine. New discoveries will continue to change the picture, because every new fossil, every re-examined artifact, and every genetic analysis has the potential to alter what we think we know about these people. There will always be shadows in this story. We will never know exactly what every Neanderthal looked like, what every group believed, how every tool was used, what every conversation sounded like, or why every population disappeared when it did. And those unanswered questions are not failures of the story, but part of what makes it worth continuing. The unknown remains there, just beyond the edge of the evidence, waiting for another discovery to bring one more piece of their world into view. And now, dear Sapiens, our long journey through the Neanderthal world is coming to its final moments. We have traveled from the deep origins of Homo through the separation of ancient lineages into the anatomy, technology, diet, hunting, fire, clothing, landscapes, and social lives of people who once called Eurasia home for hundreds of thousands of years. We began by asking who they were, and we end with a much harder question. After everything we have seen, how could we ever again think of them as simply something other than human? They made tools with patience and precision. They cared for injured members of their groups, survived wounds that would have killed people without assistance, treated the dead in ways that suggest attention and meaning, created pigments and art, selected objects for reasons that may have included beauty, and lived within social worlds rich enough to preserve knowledge across generations. These were not empty lives waiting for our species to arrive and give history its meaning. They were lives already full of meaning before we ever entered their world. Their triumphs and their failures belong to the same deep human story. Their adaptations show resilience. Their technologies show problem-solving. Their injuries show danger. Their care for others shows cooperation. Their occasional violence shows desperation. And their genetic legacy shows that the story did not end when their bodies disappeared from the fossil record. They were not merely a dead branch of evolution, because one of their branches eventually became tangled with ours. Perhaps understanding them changes the way we understand ourselves. If people who looked different, thought differently, lived differently, and belonged to another human lineage could still create, care, adapt, suffer, hunt, teach, and love, then humanity was never defined by a single body shape or a single species name. Maybe what makes the story of the Neanderthals so powerful is that, after hundreds of thousands of years of separation, we discover that their story was never entirely separate from ours. This was our journey into the lost world of the Neanderthals, a journey across time to meet relatives who left behind only fragments of the lives they once lived. We followed those fragments until they formed something larger. Not a monster, not a primitive caricature, and not merely an extinct species, but a human lineage whose story still reaches into the present. And perhaps, as you begin to drift away from this story, you can let one final thought remain. Somewhere beneath the fossils, behind the ancient tools, inside the layers of ash and sediment, there were people who once believed their own world would continue just as ours seems certain to continue now. And they could never have known that thousands of generations later another human would be sitting quietly in the dark, listening to their story. Yet here we are, and through us, in a strange and unexpected way, they are still here too. So rest now, dear Sapiens, knowing that the people who endured the ice did not vanish completely into it. Their bones became fossils, their tools became clues, their fires became traces in the earth, their voices became silence, and part of their biological inheritance continued forward until it reached us. Their journey ended as a distinct people, but some part of that journey continues every time one of their inherited fragments passes through another living human being. The Neanderthals are gone, and yet they remain. Their world is lost, and yet its echoes are still inside our world. And perhaps that is why the final silence does not feel entirely empty. Their story has reached its end, but the question it leaves behind is still alive. When we look into the deep past and find ourselves staring back, where exactly does their story end and ours begin?